Hey guys, this is part 2 of angle-angle similarity. You'll see this example in your book on the your turn, and I've also used another one from somewhere else. I can't remember exactly. Maybe this is just your turn, but anyways, let's go get started. All right, so we talked about similar triangles. If two angles of either triangle are the same, if they're congruent, then it's going to be similar. They're going to be the same shape, basically, just going to be different measurements. They don't always have to be the same exact measurements in terms of how big they are. So we have this problem here. It says Rosie is building a wheelchair ramp that is 24 feet long and 2 feet high. So you see 24 feet long, 2 feet high. Because you want this wheelchair, not probably the best at drawing stuff here, but you want this wheelchair to be able to go up in a safe manner, right? You don't want it to be too steep. And you'll notice most city municipal regulations require a certain slope on wheelchair ramps. So this is not something new. This is typical of what you see. Now, this may not be exactly what's around, but this is just an example. Okay, so what she needs to do is she needs to install a vertical support piece of 8 feet from the end of the ramp. So from the end of the ramp back 8 feet, she needs to put a support beam right here. So she needs to figure out what's the length of the support beam going to be in order for this to work, to keep that level, to keep that same slope. Because if it's too big, it'll go up here like this and then it'll drop down. It will have two different slopes. So you don't want that. You want to have the same measurement. You want to have the exact measurement 8 feet from the end. More than likely, they'll probably put another one here too, but that's not what the question's asking. Okay, so how do we figure this out? Well, you've got several different ways of doing this. Probably the best way is just set it up as a ratio or as a proportion. So what I would do is you could start with this. Start with 8. 8 is compared to what? What measurement would you compare it with 8 with? Would you compare it with the height, or would you compare it with the length of this triangle? So if you think about it, this length here, or the base of this triangle, is compared to the overall length of the bigger triangle that's inside. So you want to set 8 over top of 24. You want to set that equal to this, which we don't know what that is. Let's just call that x for now, over 2 feet. Okay, and again, this is all feet, so you don't have to write down the feet, but I'll go ahead and write that down. All right, so let's cross multiply and solve. 2 times 8 is 16. 24 times x is 24x. This is a one-step equation. We need to divide both sides by 24 because we're going to get rid of it on this side. And you should get x equals 16 over 24. Okay, as a decimal, let's see, that would be what? Let's divide both top and bottom by 4. I'll get, let's see, 4, 6. Divide the top and bottom by 2. 2/3. So basically I get 2/3 of a foot. So this is 2/3 of a foot. And if you want to know real in terms of, because it's not a full foot, if you want to know what it is in inches, set it equal to 1 foot. See what happens. So 2/3 equals, let's put 1 foot's going to be 12 inches, right? So 3 goes into 4, 3 goes into 12 4 times. 2 times 4 is going to be 8. So it's going to be either 2/3 of a foot or 8 inches. So either one of those would work. Okay? And that's that one. Let me hit the focus button on it one more time here. It gets a little fuzzy at times. I just noticed that now. Okay. And I apologize if it's a little fuzzy. Trying to make it sure as clear as possible. Okay. This next example says the lower cable meets the tree at a height of 6 feet. So this is the lower cable. This is the higher cable right here. I guess if there was a higher cable. I don't see it here, but let's say that there is. So there's a lower cable here. It meets it at 6 feet high. So this is 6 feet high, but it's 16 feet long from the base. So this is 16 feet from the base to about here. And then from here to here, this is 8. So I'm not sure where to put it, but that's basically going to be 8 right there. That's the height. So what we want to do is we want to compare, do the very similar to what we did up here in our proportion. We take our, you can actually set this up a lot of different ways. You just want to be consistent. Whichever way you decide to set it up, it's up to you. But you have to be consistent. So if you're going to take the height of the tree and compare it to the height of this thing, to this lower supporting cable, right? Then you can do that. You can do question mark over 8, and then set your longer measurement, 56, to 16. You can set it up that way. Okay, and again, you don't have to use the question mark. You can use X if you'd like. Or you can set it up yet another way. You could say, well, I don't really like that. I like to set up 8 over 16 and then question mark over 56. You can most certainly do it that way. 8 over 16, right? The height of a triangle over the length of it compared to question mark, and put down X in this case, over 56. You can do it that way too. There's actually another way you can do this, but what you want to do is you want to be consistent. So you either want to set the height over the other height, then the length over the other length, or vice versa. But what you don't want to do is you don't want to take the height of a triangle and set it over the length of the bigger one, because that really has nothing to do with 56. 16 has more to do with 56 than 8 does. 8 has more to do with what the question mark is. It has to do more with what the height of the tree is. That's why you want to really set that over top of the question mark, or vice versa. If you want to put the ratios of 8 over 16, that's fine, but you're going to have to do the question mark over 56 in this situation here. So again, it doesn't matter which way you do it. As long as you're consistent, you'll still get the same answer. So 16 times, let's call this X, is 16X equals 8 times 56 is 448. And then same thing here, 16X equals 448. You're going to divide both sides by 16. And then you should end up with 21, I believe. 21 feet. And that's what's going to happen. It's going to happen here as well. You can divide both sides by 16. You still get the same answer here. 21 feet. So that means this tree has to be 21 feet tall. All right. So that's using similarity, because the angle here, if these two lines are parallel, these angles here are going to be exactly the same. Right? This is 90 degrees, and this is 90 degrees. So you've got an acute angle here, 90 degrees here, because that's true height. Whatever this angle is, it doesn't matter. It's going to be the same angle measurement. Okay? So these are using two similar triangles, one that's really small here compared to the big one that's inside. So that's how angle similarity helps you solve these type of problems. So make sure you look in your book. You'll see these problems there in your book. Just take a look. And if you have any questions, let me know. I'll catch you on Zoom, or I'll be happy to create another example, something a little bit different. God bless, and catch you later in the next video. Bye-bye.